Today's video, we will be looking at how we can apply a herd behaviour model to a scenario involving Brexit, with regards to an investor looking whether or not to invest in the UK following the split from the EU. Herd behaviour and informational cascades. Is there really any difference between them? The answer is yes. Herd behaviour is the tendency of an individual to copy the behaviour of a larger group, regardless of the rationale involved. Informational cascades are when the personal choices are made on the observation of others, ignoring personal information. The key difference here is that an informational cascade involves an infinite sequence of agents ignoring their private signal. In the herd behaviour, the private signal is not necessarily ignored. Why is herd behaviour a problem? Herd behaviour leads to the support of irrational decisions, which can breed uncertainty for the future. It may also lead to an increase in transaction costs, as constantly changing decisions can be costly. In the context of Brexit, the global stock market was wiped of almost $2 trillion in value, as well as the pound plunging to a 30-year low against the dollar. What has herding got to do with Brexit? Complex economic events can often trigger herd behaviour, especially between investors. We can argue that the Brexit announcement came as an economic shock to investors, causing them to deviate from their private signals and look towards the actions of others rather than trust their private signal. The fundamentals of assets are ignored as a negative feedback loop forms, and this reduces prices below their asset value. The herd mentality can spread through an economy fairly easily. So now we're going to visualise herd behaviour with respect to UK financial markets in the run-up to Brexit. In our scenario, we have an investor who has the decision to invest in the UK financial markets or invest elsewhere, but the prospect of Brexit has made them uncertain. Modelling this decision in a binary format, we set A equal to 1 when they invest elsewhere, and when A is 0, they will invest in the UK. We let xi denote the event where A is 1 according to their private signal, meaning they will invest elsewhere. We let y denote the event where A is still 1, but according to public information rather than their private signal. We will then assign probabilities to these two events. We use a conditional probability of xi given y to show the probability of an agent investing elsewhere based on their private signal, given the public information available. In this example, we assume that the first agent will act purely on their own instinct. They'll follow their private signal and invest elsewhere with a probability of 60%. Despite this, in our scenario, the public information actually hints at the benefits from investing in the UK, meaning it will be beneficial for the investor to invest in the UK and disregard their private signal. This can be shown as the probability of y given x, which is slightly under 50%, hinting at a bias towards investing in the UK. We will solve the conditional probability in red using Bayes' theorem. Bayes' theorem can be shown on this slide as a combination of the probabilities of the event and some other conditional probabilities. By inputting the numbers from our example, we see that the probability of xi given y comes out as 58%. This means that the first agent will invest elsewhere, even though the public information clearly hints at investing in the UK. We now suppose a second agent, who was more inclined to invest in the UK, enters the equation. They have a probability of around 55% to invest in the UK according to their private signal. But instead, what happens is, they observe the previous agent's actions and take this into account. Using Py given x as 58% from our first agent, we see that the Bayes' theorem changes, and for the second agent has now gone to 53%. This is a 53% chance to invest elsewhere, and goes against their private signal of investing in the UK. We can now see the herd behaviour beginning to form. Assuming similar probabilities, successive agents will continue to disregard the public information and invest elsewhere. This is detrimental to the UK in the lead up to Brexit. The herd mentality will only break down when a rational individual comes along and listens to the public information and acts upon the public information. However, in this example, if we kept the assumption of homogeneous private signals, this herd would lead to an information cascade, as their private signals are ignored and the signals of the previous agents are taken into consideration. How can we overcome herd behaviour and how can we prevent it in the future? The transparency of information and access to education are key drivers behind the process of reducing the herd mentality. Herd behaviour relies massively on the irrationality and uncertainty in order to succeed. If we can monitor this and combat it through the means of informational transparency, then we are likely to be able to limit the effects of informational cascades and herd behaviour, especially in the run-up to Brexit.